A very good morning, my dear students. Hope everybody is well. Let's begin the topic. Within 2 to 3 classes, hopefully at the end of this particular online classes session, we will be finishing the current chapter called Motion in a Plane. What is the current chapter? Motion in a Plane. Now, in these 2 3 classes, what is the content we are going to learn? Let me tell you here. Motion of a boat, carefully see, in a river or river man swim means, so there is a person who is swimming in the river. So this is the topic. Or there is a boat which is moving in a river. And the next topic will be on this in these 2 3 classes I'm talking about. The next class, next topic will be rain man topic. Means there is a man who is walking or running or cycling in the river. So there are a lot of things related to these topics will be discussed in this chapter. These are the last 2 topics in this chapter. Let's start the concept, my dear students. The topic of today's discussion is motion of a boat. Motion of a boat in a river. All right, motion of a boat in a river. So there will be 3 cases involved in motion of a boat in a river. 3 cases. Simple cases, important cases are involved. So the neat diagram I'm just going to draw here, a very simple and neat diagram, my dear students. You can see this is the river, and let's consider the width of the river is d. What is the width of the river? These are the commonly asked questions in the NEET exams. You can expect definitely one question from this topic, motion of a boat in a river and the river and man. From these 2 topics, one question can be asked. So simple. So what is D here? Width of the river. Width of the river. Now, this is the flow of the river, my dear students. This is the flow of the river. Okay, so this is the flow of the river. So this flow of the river, I'm just representing with a vector form. So this is what the flow of the river. So flow of the river, I'm writing it as velocity of the water with respect to ground. Carefully see. Velocity of the water with respect to ground. So the same thing I'm writing here. VWG, that is equal to velocity of water with respect to ground. Velocity of the water with respect to ground. Here comes an important point. What we have discussed in the lower classes, that indicates, like in the last sessions, relative velocity in 2 dimensions. What we discussed, VA bar is equal to, so that is VAB bar. Okay, so VAB bar is equal to VA bar minus VB bar, isn't it? What is this? Relative velocity or velocity of A with respect to B, which is equal to VA bar minus VB bar, right? So in the same way, you can apply here VWG bar. So you know what is meant by this VWG bar? Velocity of water minus velocity of the ground. What is this ground velocity? Always the ground velocity will be zero, isn't it? So ground will never move because we are on the ground. So we consider the ground is at rest always, because we are not looking the ground from the other planet. Understand? So this we consider as zero. So that indicates velocity of water with respect to ground is equal to velocity of the water only. But as we are talking about the relative velocity, always we'll write with respect to what? Understand? So this is the important. So velocity of water with respect to ground is in this direction. This is called the flow of water. Now, this is the flow of water or flow of river, anything. Now, velocity of, carefully see, velocity of the boat with respect to water. Look at here. So what is VBW? Velocity of boat with respect to water. Remember, always this is the velocity of boat with respect to still water. What is this water? In the sense, it is still water. These are the common notations and the assumptions you must make it, right? So velocity of the boat with respect to still water. Water in the sense still water. So the, the boat will assume the water is at still and moves. That is called velocity of the boat with respect to still water. Respect to still water. In a question, if they have given that velocity of the boat with respect to water, you must think that the velocity of the boat with respect to still water is given. Okay. Now, velocity of the boat with respect to ground. So these are the three common notations you must understand before going to this topic. So this is the topic is nowhere connected to your lower classes of 9th standard, 10th standard. Okay. So that is why you be careful about these topics which you have not yet studied anywhere, right? The first time you are studying this motion in a plane, in which motion of a boat in river and riverman topics. So the third notation is velocity of the boat with respect to river. So the combination of these two, or the resultant of these two will be given by this one. So what is this? Velocity, see, in more detailed way, the velocity of the boat with respect to ground we'll discuss, don't worry, right? So VBG bar is velocity of the boat with respect to ground, my dear students. VBG bar is equal to velocity of the boat with respect to ground. But let's discuss in a detail. For example, this is the flow of water. In the flow of water, there is a boat is moving. So this is called the velocity of the boat with respect to water. Understand? So you must consider this as velocity of the boat with respect to still water, or velocity of the boat in the still water. So now the boat is moving in the direction of flow of water, you can see here. Okay. So if a person who is standing on the ground, or who is called as an observer, for him, what is the resultant velocity? So that is called this one, velocity of the boat with respect to ground. Okay, velocity of the boat with respect to the person who is on the ground, but the velocity of the boat is the combination of this flow of water and his own initial velocity of the boat. Okay, clear? Now imagine if the same person is moving with the boat velocity with respect to still water in the opposite direction of the flow of water. In this case also, he will observe the velocity of the boat with respect to ground. So in this case also, the velocity of the boat with respect to ground is the resultant of these two: velocity of the water with respect to ground and velocity of the boat with respect to still water. Students, I hope it's very clear to you what exactly meant by this VBG. That's a resultant of these two. Let's discuss about the formulas. Formula we have not yet started, right? We are just discussing the topic only now. Now, in the motion of a boat in a river, there are three cases I told you. In three ways the boat can move in this river. Number one is downstream. What is the downstream? Just now we discussed about the downstream. Downstream is if the boat is moving along the flow of water, that's called the downstream. This is the first case, right? So boat can move in the downstream. And number two, what is the second case here? The second case is upstream. Boat can move in the opposite direction of the flow of water. That is called upstream. That's second case. Third case is also there. Third case, the boat is crossing the river. Okay, so imagine this is the point where the boat is trying to cross the river. This is the velocity of the boat with respect to still water. See here. So this is velocity of the boat with respect to still water, where the boat is moving along the flow of water. In the second case, boat is moving opposite direction to the flow of water. In the third case, the boat is trying to cross the river. So while crossing the river, there are so many other cases are involved. Let's discuss them later, right? Let's focus on this downstream and upstream. So this is called while crossing the river. Okay, while crossing the river. Just for your better understanding, so let me tell you here. So while crossing the river, the boat can cross in any other way, right? Here, the boat is moving perpendicular to the flow of water. So the boat can move in this way to cross the river. Boat can move in this way to cross the river. In any way it can move, right? So crossing the river is an other topic. Let's focus on downstream and upstream. All right, clear? Now, downstream and upstream. Here. Downstream. Let's concentrate on downstream. Downstream, velocity of the water with respect to ground and velocity of the boat with respect to water. Imagine. And the resultant is this one, velocity of the boat with respect to ground. Velocity of the boat with respect to ground bar is equal to F. When two vectors are in the same direction, the resultant, you know how to find that. The theta is 0 here, okay? Theta is 0 here. So you can find the resultant vector in this way. VBG bar, the resultant of these two will be equal to VBW bar, right? Minus VWG bar. Okay. VBG bar is equal to plus VWG bar here. So this, as theta is equal to 0 in this case, my dear students, if you use parallelogram law of vector addition, the resultant you get it as VBG is equal to VBW plus VWG. Okay, this is the resultant. All right, so simple. This is the magnitude, this is magnitude, this is magnitude. Imagine if this BW is 2 meters per second. if this is 1 meter per second, so in the downstream, the net speed of the boat with respect to ground will be just adding these two, 2 plus 1. So finally the net speed of the boat will be 3 meters per second. That's it. Or 3 kilometers per hour. If it is 2 kilometers per hour, if it is 1 kilometer per hour, so this will be 3 kilometers per hour. It's so simple. All right. Clear? For example, D is the distance covered, or I can say X is the distance covered. Simple. Right? With this speed, if the distance covered is X, covered in time T1. T1 is time taken in the downward stream. So T1 is equal to distance covered is how much? X. With what speed it is covering distance? VBW plus VWG. Okay, so that is the downstream. And upstream also we can discuss here. Upstream. It's not difficult task. Okay, upstream also we can. Same thing. So VBG is equal to, let's write about the magnitudes. Okay, VBG is equal to VBW minus VWG. So if you carefully see, you may think that why it is VBW minus VWG, why not VWG minus VBW? Because in upstream, always velocity of the boat in the still water must be greater than velocity of the water with respect to ground. Let's concentrate on upstream. Velocity of the boat must overcome the velocity of the water. Okay, velocity of the boat with respect to water, with respect to still water must overcome. If the flow of water is 1 kilometer per hour, if the flow of water is 1 kilometer per hour, the flow, the motion of the boat with respect to still water must be greater than 1 kilometer per hour, isn't it? Otherwise, how the boat can overcome the speed of the water? Remember, always this must be the greatest. So this resultant is this one, and here the resultant. In this case, same. If X is the distance covered, if X is the distance covered in time T2, my dear students here, right? In time T2, so what is the T2? That is important. What is T2 here? T2 is same X by the resultant speed here. So VBW minus VWG. All right. So this is the T2 in the upstream. So this is in the downstream. Sometimes the question will be asked about the ratio of T1 by T2. You can find sometimes the sum T1 plus T2, sometimes the difference T1 minus T2, right? You must be very careful about this. So remember these notations. VBG bar, velocity of the boat with respect to ground. VBW bar, velocity of the boat with respect to water. VWG bar, velocity of the water with respect to ground, right? So take your own time, just go through each and every notation and each and every formula I discussed right now. Just pause your video, write down your notes properly and do that. Okay, now let me give you one more important area where you can focus. Imagine the situation here. Boat engine is switched off, right? So that means velocity of the boat with respect to still water is 0. So that means boat is not moving, but there is a flow, right? Velocity of the water with respect to ground is not equal to 0. Understand? There is a flow. So in this case, what is the velocity of the boat with respect to ground? We have the formula here. Definitely it will be called as downstream, because the boat is just kept over there. That's it. The engine is switched off. So then it will flow with the water. So whereas in this case, if a person is sitting on the bank of the river or the shore of the river, what happens for him? The velocity of the boat with respect to ground will be equal to, see here, let's look at this formula. Velocity of the boat with respect to water is 0 plus velocity of the water with respect to ground. Okay, so velocity of the boat with respect to ground is equal to velocity of the water with respect to ground. That's it. The boat will flow with the water. Remember this. In this case, time taken is equal to, if the distance covered is x, for example, in this case, the free flow, if the distance covered is x, the time taken will be distance by speed. Speed is velocity of the water with respect to ground. So three cases we discussed, my dear students: downstream, upstream, and downstream, and free flow, right? That is called what? Free flow. Downstream only. Okay, clear. Let's have a look at how the questions will be asked on this. Right? Let's see this example question. Just a second. Look at here. A person can swim in still water at 5 meters per second. He moves in a river of velocity 3 meters per second. First, down the stream. First, down the stream. Next, same distance up the stream. Same distance up the stream. The question is the ratio of times taken. What is the question? The ratio of the times taken. Let's look at here. A person can swim in the still water at 5 meters per second. Can I say this is velocity of the person? Here, in the place of person, let's keep a boat, because we have discussed each and every formula with respect to the boat. So in terms of boat only. So that's why I can write velocity of the boat with respect to water. I told you the water you must consider initially as still water. So velocity of the boat with respect to still water is how much? I'm talking about the magnitudes, right? Everything they have given as magnitudes. Velocity of the boat with respect to water is 5 meters per second and moves in a river of velocity 3 meters per second. Okay, so velocity of the water with respect to ground is also given as magnitude 3 meters per second, my dear students. First, down the stream, the same distance up the stream, the ratio of times taken. So the question is to find T1 by T2, my dear students, right? T1 by T2. What we know already here, this is the flow of water. This is velocity of the water with respect to ground. In the upstream, this is velocity of boat with respect, sorry, in the downstream, velocity of the boat with respect to water, right? Its magnitude and this magnitude. What is the resultant here, my dear students? The resultant of this is velocity of the boat with respect to ground. We have this formula, that is T1, which is equal to distance traveled is d, I am imagining, by velocity of the boat with respect to ground. And T2 will be same distance by velocity of the boat with respect to ground. Okay, in the T1, fine. In the T1, what is T1 here? Distance traveled is d, that is what they have not mentioned anything, and the resultant velocity in case of downstream. What is the resultant velocity in case of downstream? Just adding these two magnitudes. So velocity of the boat with respect to still water plus velocity of the water with respect to ground. Here T2 is equal to d by velocity of the boat with respect to water. This is the downstream final answer, final formula is VWG, right? Just go back, you'll understand. So just substitute everything. Your T1 is d by, so VBW is 5 and this is VWG is 3. 5 plus 3, it is 8, and T2 is equal to d by 5 minus 3, it's 2. Okay, so the answer, the question is T1 by T2, which is equal to d by 8 divided by d by 2, right? So this I can also write d by 8 into this d by 2 takes to taken to the numerator, that will be 2 by d, so d cancel, so the answer is 1 by 4. So what is the ratio of T1 and T2? It's 1 by 4, my dear students. That's it. In this way questions will be asked. So this is the concept of upstream and downstream, and not more than this, right? So if you know this basic question, if you really understand this basic question, and rest of the questions you can easily make it up, right? Now, the next concept is called crossing the river. Here comes an important area, crossing the river. So now it is just flowing the what, so moving the boat in the flow of water and opposite to the direction of flow of water is done. Now crossing the river. See here, crossing the river. There are two cases in the crossing the river. One is crossing the river in the shortest distance. Crossing the river in the shortest distance. Crossing the river in the shortest time. Shortest time. So these two things also with respect to the observer only. That is very important. With respect to observer. Observer, that means the person who is sitting on the bank of the river, he should feel that. He should feel that. So the boat crossed the river in the shortest distance. The boat crossed the river in the shortest time. Okay. Now, this is the width of the river. You know, each and everything. This is the width of the river. So what is the D here? I'll write somewhere here. So D is equal to width of the width of the, okay. Now imagine he is the observer on the ground. What is shortest distance? Carefully see. Let me explain the both the things here, then we'll understand the formula. Number one, the first thing. It's not the difficult task, it's simple. First thing, shortest distance. What is the shortest distance? This is a point A where the boat is starting. Shortest distance. Shortest distance is the straight line distance between initial and final. This is the shortest distance. No, always a straight line distance is the shortest. Now, if you observe this point, this is called the shortest distance in crossing the river, A to B. You draw any other straight line in this way, or in this way, or in this way, right? That is never called a shortest distance. This is the shortest distance. So the aim is to move in case of shortest distance. So let me write here. In case of shortest distance condition, aim of the person is to move from A to B. Flow of river is this one. Velocity of the water with respect to ground is in this way. Okay, this is what the velocity of water with respect to ground. Flow is there. River flow is there like this. No confusions. River flow is there here also. For your better understanding and writing. So river flow is there. Okay, this river flow is actually in this. Now, the aim is to move from A to B. But imagine if he really starts from A in this way, where the flow of water is in this way. So definitely the water will be pushing the boat in this direction. Yes or no? Water will be pushing the boat in this direction. Clear? In this direction, in this direction, in this direction. Finally, the boat will never reach to the point B. It will reach to somewhere point C. Is it clear? So to cross the river in a shortest distance, definitely the boat must to move in this direction. Will you agree with this? If the boat is started moving in this direction, slowly the water will be pushing the boat in this direction, so that the resultant, in a resultant way, the boat will definitely reach to the straight point called B. Again, I'm telling you. If the boat is starting in this direction, my dear students, definitely it will never reach to the point B, because it is not the still water. Here the water is flowing. So because of the flow of water, the boat will get pushed away and it will never reach to the point B, it may reach to the point C. So to move from A to B exactly, so the boat must move in this direction, right? In which direction? In this direction, my dear students. In this direction, the boat must move. Okay, in this direction, the boat must. All right, so this is the. Now, what is this direction here? This is called initial direction of velocity, right? So initial direction of boat. So that is called velocity of the boat with respect to still water, my dear students. Velocity of the boat with respect to still water. This is velocity of the water with respect to ground, right? See, initially the velocity of the boat is making some angle theta with the shortest distance. The velocity of the boat is making some angle theta with the shortest distance. Then it starts moving in this direction, slowly it will be pushed by this flow of water and finally reaches to this point B. Okay, so then the shortest distance will be clear. So what is this A to B path? So this is one vector called VBW. This is another vector called VWG. And what is this? So now here comes the concept called observer. For him who is sitting at the bank and observing the situation, he'll exactly feel that the boat is moving from A to B always. Because of the resultant of these two, this man will feel that the person who is on the ground feels that at any instant the boat is moving only from A to B, only from A to B, only from A to B. That's called velocity of the boat with respect to ground. I've told you clearly that is a resultant of these two, resultant of these two, resultant of these two. All right, clear? In the shortest distance, right now, according to triangle law of vector addition, so these two vectors are in the order. So what is that? VBW bar plus VWG bar, which is equal to VBG bar. Okay, so this is it. Now from here, what I can write by using Pythagoras theorem, right? By using Pythagoras theorem, what I can write here, VBW square is equal to VWG square plus VBG square. So if I take the magnitudes, okay. So from here, VBG, that is very important, right? What is the resultant of these two velocity vectors? That is very important. That's why from this equation, VBG square, which is equal to VBW square minus VWG whole square. So this is called the shortest distance condition. So here VBG is equal to square root VBW square minus VWG square. Okay, so there's no advanced level mathematics is involved here, my dear students. Right here, it is just the parallelogram law of vector addition, Pythagoras theorem, and the previous concept what we have discussed about the terminology VBW, VWG, VBG, right? So these are the things involved. Okay, so remember this equation. Okay, clear? Now, what is the time taken in this case to cross the river? That is not the shortest time, right? What is the time taken to cross the river in this case? Let's have a look at it. Time taken to cross the river in this case. See here, always the time taken is equal to distance covered. That's called the width of this, right? Width of this. And time is equal to distance by speed in that direction, right? This is the distance vertically, right? This is the vertical distance. What is the speed in this direction? VBG. Okay, VBG. Here, one more point. This is the time taken. One more point here. Commonly, you can expect the question is to cross the river in the shortest distance. To cross the river in the shortest distance. Again, to cross the river in the shortest distance, with what angle? With the vertical, the boat should start. This theta. If you know these three values, VBW, VWG, VBG, then directly you can make any theta, like cos theta, you can get sin theta. If you apply, you will get it. Tan theta, if you apply, you will get it. Imagine we have VWG and VBW. So the theta you can find, right, by using sin theta, my dear students. What is sin theta? Sin theta is equal to opposite side. What is opposite side? VWG by what is hypotenuse? This is the triangle, right? Opposite side, adjacent side, and hypotenuse. Hypotenuse is what? VBW, right? If you apply this sin theta, you will get the answer. For example, you don't know this hypotenuse, and you know opposite side by adjacent side. That's called tan theta, right? Find this. Now, one more in this equation. See, we are talking about shortest distance only, right? 90 degrees is this. Listen carefully. This is the theta with the vertical. Initial velocity of the boat is making theta with the vertical. So what is the theta required with the flow of water? For shortest distance. It's so simple. This is the flow of water, right? So here velocity of the water with respect to ground, I can also this one. Velocity, I can also write here. Velocity of the water with respect to ground. See the same velocity vector. This is one velocity vector. This is another same velocity vector. So I can write the duplicate vector here. So the boat initially is making an angle, this theta plus 90 degrees with the flow of water. This is the theta will be theta plus 90 degrees. And what is this theta? This theta we know, sin theta. Okay, from here this theta you know. So remember this. This is the complete concept about the short distance, my dear students. Just making the diagram is most important. All right. again I'm telling you, making the diagram is most important. When they say shortest distance, and remember, the boat must not start from the perpendicular. It must start at some angle with the vertical, so that because of the constant push of the flow of water, it will reach to the aiming point called B, which is at the other bank of the river. Okay, clear? So just pause the video and write your notes properly, and check with each and every line once again and each and every formula once again. Time taken to cross the river is T is equal to D by Vg. D by Vbg, right? So what is this Vbg? This Vbg you have already this one, right? So this is important. Just substitution of this. Only here only we wrote the vector form. So in most of these formulas and most of these cases, so we use only the magnitudes only. They give the magnitude. Velocity of the boat with respect to water is 5 km per hour. Velocity of the water with respect to ground is 2 km per hour. Velocity of the boat with respect to ground may be 3 km per hour. So they give you in terms of magnitudes. Now, let's see the shortest time condition. Shortest time. Shortest distance is that, right? Shortest time. For the shortest time, so this is what? Um, Velocity of the water with respect to ground. This is point A and this is point B. For the shortest time, the boat must start in this direction, right? Must start at an angle 90 degrees with the flow of water. The boat must start perpendicular, means 90 degrees with the flow of water. If it is flow of water, it is 90 degrees, right? This is the shortest time. But in shortest distance, we have not moved in this way. Shortest distance, we have moved in this direction. But here it is not like that. Here, shortest time, whatever may be the distance I travel, but I need to go to the cross the river in the shortest time. So for this observer who is standing here, he will observe the boat is moving in a shortest time if the boat initially start in this direction, right? What is this velocity of, let me draw this here. So boat is initially starting in this direction to the point B. Okay, so here this is called a velocity of the boat with respect to still water, my dear students. This is velocity of the water with respect to ground. Okay, so imagine this is the velocity of the water with respect to ground, this one. Now, definitely there is a constant push by the flow of water, and finally, this boat will reach to this point. Finally, the boat will reach to this point. So this is called velocity of the boat with respect to ground. So this person will observe that the boat is moving in this direction. Okay, but it has started in this direction to cross the river in the shortest time. So to cross the river in the shortest time, it should move in this direction. To cross the river in the shortest distance, it should move in this direction. Okay, this is the first case what we discussed. This is not required here. Now, here, velocity of the boat with respect to water plus velocity of the water with respect to ground, which is equal to velocity of the boat with respect to ground. So this is the same expression like in the last case, same expression, my dear students. But the Pythagoras theorem expression will change here. Pythagoras expression will change. How? Okay, this VBG square is equal to VBW square plus VWG square, right? See here, VBG is equal to square root VW square plus VWG square. Okay, clear? So this is VBG. Now, our aim is to find shortest time. Look at here, the shortest time or minimum time, no confusions. Minimum time or the shortest time here, T minimum is equal to distance. So here also the width of the river is D only, D by, I've told you clearly, time is equal to distance by speed in that direction. Distance by speed in that direction. So distance is D, that is the vertical distance, D. By speed in this direction is D, V, BW. Okay. So this VBW, you can write from here. What is that? VBW square is equal to VBG square minus VWG square. So any two sides, if you know, according to the Pythagoras theorem, the other side you can easily find out, right? From here, what is required? VBW. So VBW is equal to square root VBG, right, square minus VWG square. So just substitute these two things and you get VBW. Okay. Now this is called drift. What is this drift? Actually, it is started in this direction. If the water is not flowing, definitely the boat will reach here. As the flow of water is there, so there is some drift is taken. As the flow of water is there is some drift is taken by the boat. So that the drift is called X. What is that called? A drift is X. And you can see here, so the angle made by the time it reached to the maximum drift here, the angle made by the boat is theta, right? So the angle made is theta with the vertical by the time it reached to the maximum horizontal distance in this way, X. So I can say here the drift is equal to, what is the drift, which is X. X is equal to a drift, it's the distance. So distance is equal to speed into time. We are talking about horizontal direction. Horizontal direction speed is how much? VWG into distance is equal to speed into time. This is speed into time. What is the minimum time here? The minimum time is D by VBW. Okay, that's called the drift. What is this? This is called the drift. Right? Clear? Now, one more important point here. This theta also you can find. What is this theta? If you know this value, so this you can find. Theta is equal to, imagine that let's write it in tan theta terms. Tan theta is equal to VWG by VBW. So this is called shortest time. Shortest distance is done and shortest time is also done. Okay? Now, this is an easy way of learning this, right? So many students have seen they'll be having a lot of confusions in this case. Just you practice 2 or 3 times today, whenever you get free time. Today itself is just practice and this concept will be very clear to you. And it will be so much clear to you if you solve just one sample question for today. The shortest time and shortest distance, you'll understand it very well. Let's see. The question is the velocity of water. The velocity of water in a river is 2 km per hour. width width is 400 meter. A boat is rowed from a point. A boat is rowed from a point. Rowing always aiming the opposite point, always aiming the opposite point at 8 km per hour of still water velocity. On reaching the opposite bank, the drift obtained is, look at this. The velocity of water in a river is 2 km per hour. What is this given data, my dear students? The velocity of the water with respect to ground. I told you, always the magnitudes will be given. 2 km per hour. With the width of the river is how much? 400 meters. A boat is rowed from a point. Rowing always is aiming the opposite point. Always aiming the opposite point at 8 km per hour of still water velocity. So velocity of the boat with respect to still water is what? 8 km per hour. Here comes the important point. You can see by reading this statement, you can come to the conclusion that which case it belongs to. So a boat is rowed from a point, rowing always aiming the opposite point. Okay, let me draw a rough diagram here. So this is the river, one bank, and this is the other bank. So width of the river is D. Carefully see, starting from this point A, and the boat is initially or always trying to aim to reach to the point B. Definitely because of the flow of water, it will reach to some other point C here. So this is called the drift. So when they talk about the drift, and when they are talking about it is always aiming the opposite point, so then this is the condition called a minimum time condition. Will you agree with this? Shortest time condition they gave. It's not the shortest distance, because we'll never discuss about a drift in case of shortest distance. All right, now then what is a drift? Drift you can easily find, right? So what is the drift? Drift x is equal to, what is this velocity in this direction, which is velocity of the water with respect to ground into time. So that is the minimum time. So minimum time we had already discussed. VWG is equal to T is what? Minimum time is distance by the speed along the distance. What is this velocity of the boat with respect to still water, my dear students? The velocity of the boat with respect to still water. So that x is equal to, what is VWG given as 2 into what is D? It's 400 divided by what is VBW? It's 8. Okay, so this is 2 4 and 400 by 4. It is 100 meters, my dear students. So what is the drift here? It is 100 meters. Okay, clear? Oh, no, it's 100 kilometers. It's everything is given in it's a 400 meters, right? So this is meters and this is kilometer per hour. Kilometer per hour cancel. It's exactly, it's 100 meters. Okay, sure. All right. So this is how the concepts we can discuss. let's revise what are the concepts we have discussed for a small time. We have started with the motion in a plane, and today we have finished motion of a boat in the river, or a river man who is swimming, or the boat which is rowing in the water. This river. So in the motion of a boat in a river, there are two cases: downstream, upstream, and crossing the river. Downstream, the velocity of the boat with respect to water and velocity of the water with respect to ground need to be added. In the upstream, the magnitudes need to be subtracted and the time taken to be discussed, right? So for example, when the engine switch is off, then the boat will flow with the flow of water. That case also we have discussed, my dear students. That case also we discussed here. And later, and in here itself, these three are very important. The three notations are very important. Okay, now what we have discussed here, this is a simple numerical we had learned. Upstream and downstream, the ratios of time, they give the values of velocity of the boat with respect to water and velocity of the water with respect to ground. Just upstream time, sorry, downstream time and upstream time, the ratio of these two. Later, the most important concept for NEET is crossing the river. Crossing the river, two cases are there. River can be crossed in the shortest distance and river can be crossed in the shortest time. Shortest distance we have learned here, right? To cross the river in the shortest time, the person need to start at some angle with the vertical. He need not start in this direction. If he start in the direction of A to B, he'll definitely reach to the point C. That is the another case, okay? So to cross the river in the shortest time, you must start at some particular angle here, my dear students. Then only it is possible. After that, so according to the vector laws of addition, we have got this equation. According to the Pythagoras theorem, so we have got this equation. Okay, so then we always need an expression for velocity of the boat with respect to ground, because for the observer, then the time taken to cross this river, this is not the minimum time, my dear students. Again, I'm telling you, this is just the time. There is some time will take to cross the river in this direction. So what is that time? Is this time taken to cross the river in this case? That's the shortest distance case. That is d by vpg. Okay, so this is angle. With what angle you need to start, so that finally you'll cover the distance. You'll cross the river in the shortest way. So that is this theta. Then the shortest time. If he need to cross the river in the shortest time, he must start vertically in this time. Okay. So here shortest time expression we have got, and drift expression also we have got, and here also by using vector laws of addition and by using Pythagoras theorem, we have found velocity of the boat with respect to ground, right? So this is the tan theta here. Here, one more thing. In this case, displacement you can find, my dear students. Displacement. What is the displacement in this case? Look at here. Displacement, imagine this is AC. AC is the displacement, which is equal to, see here, this is D, right? Distance I'm talking about. This is D and this is X. So what is the displacement here? Square root. This is AC is equal to Pythagoras only. D square plus X square. So displacement you can find it, because displacement is a straight line between initial and final position. Next. Okay, this is a question we have done. Here displacement can you find? So this is the D. This is X. Okay, this is D, vertical line here, and horizontal line X, and you can find this displacement, right? So let's find the displacement AC. Find out. Just give me the answer. What is the displacement in this case? In terms of meters you will get, because D is given as 400 meters. And I got X drift as 100 meters. Find out the displacement and text me now. All the very best. The next class will be discussing about river man problems, then numericals, right? And some more numericals. Thank you so much.